Hey everyone, my name is Bidi Peter Mnyenyembe and I'm here for a very special program. We are here to embark on a journey of introducing a discovery that one amazing man has been working on for the past 40 years. I'm sure you might be wondering by now, what is that exactly? When you look at a computer, most of you might think a computer can solve nearly anything. More especially by the introduction of AI tools, most of the things looks to be possible by using a computer. But the fact is, there are many things that a computer cannot solve. And one of those is what Dr. Lemba Nyilenda has actually discovered. And like I mentioned, he's been working on this for the past 40 years. So enjoy as he's going to take us through this journey.
My name is Dr. Lemba Nyilenda. I'm a graduate for the first degree from the University of Zambia in the Bachelor of Electrical Engineering and a master's degree in Power and Operations Research from the University of California, Irvine, and also a PhD holder of the University of California, Irvine in Electrical and Computer Engineering. Currently, I am a lecturer in the Department of Electrical and Electronic Engineering. But at the same time, I've been conducting research in problems that cannot be solved by a computer for the past 40 years. The motivation for conducting this individual research for the past 40 years, from 1986 to 2026 to date, is for Africa to be able to have strategic core networks in place that cover roads, air travel, water, electricity, communications. These are known as lifeline infrastructure. The way it is as we stand right now, most of this infrastructure is in a disaster state. But to put them in place, you require to utilize these problems that cannot be solved by a computer. Mostly the mobility spanning tree problem and the transportation traveling salesman problem. But these problems are declared from the mathematical point of view, even as millennium price problems that they cannot be solved. So for us, it is imperative that they are solved for us to be able to integrate them in the Africa peace formula. In this individual research journey, God has been my CEO. And the insights in this direction are influenced by what we find in Matthew chapter 19, verse 22 to 26. Here we find two NP spiritual problems. The first one is that it is impossible for a rich man to enter the kingdom of heaven. The second spiritual NP problem is that Jesus says that it is easier for a camel to enter the eye of a needle than for a rich man to enter the kingdom of heaven. Then it's followed by a statement where Jesus says, this is impossible with man, but everything is possible with God. This statement gives us the divine NP equal to P proposition. Following this proposition, basically it is showing us that if there's a spiritual transformation of the camel and the needle, they can pass in each other. In the same manner, for the mathematical problems that are impossible to solve by computer, it implies that what we need to search for is the transformation to transform the impossible problems, which are NP hard, to problems that are possible to solve, or NP easy, through the transformation. And indeed, it is in that direction that we shall be able to present the exploration that led to that. In order to put in practice the divine NP equal to P proposition as regards the impossible mathematical problems, namely the mobility STP and the transportation TSP. One thing that is common is that these two problems are defined on a network. Now, when we look at physical networks for roads, electricity, and power, their mathematical model is derived from graph theory. So that particular model, usually it is a distance matrix which shows the from to nodes. Those are the only things that are accessible. But when you have modeled a network as in graph theory, then the solution itself, because it involves the distances, but you would have no access or capability to well order those words. Hence the impossibility to solve the problem. However, I took on the journey of studying 10 branches of mathematics. The key ones are in discrete optimization. That's what gave us the supermodular algebra and the submodular network algebra formulations. Then moving on to real analysis, real analysis. There we find the Cantor-Dedekind axiom. That axiom is equivalent to Zermelo's well-ordering principle. And this formulation showed us that we can be able to well order the words that are in the distance matrix. By doing this, when you well order the distances that we have in there, we can transform any weight matrix to the Dedekind-Cut periodic table. This periodic table is in line with what Mendeleev did for the chemicals in 1869-70. With this transformation, the optimal solutions for both STP and the TSP, they just cluster themselves. And in this manner, we've jumped the impossibility barrier. So far, we have talked about coming up with the distance periodic table, in which the solutions for the STP and the TSP, they cluster in fixed positions. Basically, the discoveries that we have from this are two. One, it is the third network dimension. So this research has brought about the discovery of the third network dimension. That is the indices for well ordering the weights inside a distance matrix. The fact that the STP is easy to solve now with this transformation, given that most of our lifeline infrastructure in Africa, starting from Cape to Cairo, from Dar es Salaam to Accra, they are in the disaster state. But for us to create the strategic core lifeline networks, we need the mathematical solutions. These mathematical solutions of the mobility STP and the transportation TSP will make us to be able, combining it with the algebra, the submodular network algebra and the supermodular network algebra, we can be able to have the Africa TSP computer and the Africa STP computer to assist in coming up with a strategic core road network, power network, communication network. The next steps is to be able to share the genesis or the direction on how we can come up with these computers and also implement it as part of the Africa peace security formula, which requires that we also have at the Africa level the Africa Brains Brigade, which require that we bring together communities, universities, and the military to be think tanks in this process, but utilizing the Africa STP computer and the Africa TSP computer. So far, what has been covered is of great importance in implementing the Africa Peace Formula within the 2063 agenda of the African Union. There we find that with the propositions that we are talking about, the renaissance of computer science and engineering throughout Africa is going to occur. At the same time, Africa is going to be a peaceful continent in the sense that we are going to be able to have mobility and transportation avenues that are properly designed and enhancing the peace and security of the continent, as well as prosperity. So it is hoped that the African Union Commission would be able to propagate the message we're having. And this message is starting from the youth all the way to those who have discovered technologies, but they need to be qualified under the ACFTA mode. That's our hope, that we will work together in the next presentations.
Wow, just wow. I believe by now most of you have got 1,000 questions. Some of you might be wondering, is this an algorithm that you can put in a classical computer, or perhaps a quantum computer? Or maybe is it a very different to these computers that we know? Well, let's find out on the next episode.